Okay, so first thing I asked on the quiz was expand x minus y times x plus y. So you use the distributive law, you get x times x plus y minus y times x plus y. And that equals x squared plus xy minus yx plus y squared. Yx is the same thing as xy. This leaves you then x squared. That should be minus y squared. X squared minus y squared. And then when factor 36a squared minus 6b squared, well, this is in the form x squared minus y squared. X is 6a and y equals 8b. It's not b squared, it would be to the 6th. Okay, so get 8b. What power of b would you square to get b to the 6th? It would be b to the 3rd. So easier to read. I'll say the alternative form x minus y times x plus y is thus 6a minus 8b cubed times 6a plus 8b cubed, because of course we've specified that this has this form, if x equals 6a and y equals 8b cubed. Since this form is identical to this form, it's equal to this form. Then if I use that x and that y in this form, like here, this is what I get, and that's the factored form. Okay, so that's called, as you know, from the open math assignment, that's called using the difference of two squares, factoring the difference of two squares. That's something that comes up commonly. Okay, well, next thing we want to do, and we're still pretty much talking about distributive law for a while here. Let's say we have five x cubed y to the 4th minus 35 x to the 5th y squared. Well, I could rewrite this using the distributive law. That makes it clear why this works. I can rewrite this as 5 times the quantity x cubed y to the 4th minus 7 x to the 5th y squared. I can identify that 5 and 35 have a common factor of 5. Now there's more I could do. I could say that this equals, why not 5x y times something, okay? And I should have had an equal sign there, okay? What will go in the parentheses to make this equal to this? See if you can do that. Okay, so we got this, everybody got this. You multiply this by x squared, y cubed minus 7x to the fourth, y. It's gonna work, right? Well, we're still gonna want to have 5xy here. Let's say we don't want that y there. Okay. Well, then we could simply use 5xy squared, right? And that's going to give us x squared, y squared minus 7x to the fourth. Well, that's the highest power of y that's common to both of these terms. So we can't take any higher powers of y out of this expression. But what more could we do with x? What's the highest power of x that we could put here, still get something sensible inside the parentheses? Okay, well, we can take another power of x and write 5x squared, y squared, and then that would be, of course, you want to look back at the original expression to make sure you're in agreement with it. If I have an x squared here, I'm going to need another x here in order to get the x cubed that we started with. Okay, so we could take the x squared out, we'd be left with an x here and an x cubed here. But if we do it with an x cubed, then we're going to have no x, we're going to have y squared minus 7. And we close the parentheses a little quicker on that. Then we want to check and make sure that really does it. Well, we want to compare with what we started with. But x cubed y squared times y squared is going to give us y to the fourth. We have the 5, so we're going to get this term. And then 7 times 5 is gives us our 35, or a negative 35 in this case. And then we have, I don't know why I did that. We don't have what I just said. We have 7, and we've got x cubed here, but we need x to the fifth. It's going to be 7x squared. Okay. So don't necessarily want to look back at the previous step, because really, we're not going to do these steps. We're going to look for the biggest thing we can pull out. Okay. So we can just see it if we ignore these steps. We see that we have an x cubed here and an x to the fifth here. That means we can factor out an x cubed, which is what we ended up doing. And we don't need to go through these steps here. Of course, we have a 5 and a 35. We can factor 5 out of that. And we're going to have the 1 here and a negative 7 here. And then on the y's, we have a y to the fourth and a y squared means we can factor out a y squared. So we can see if we have 5x cubed y squared here, there's something we can multiply by this to get this term. That's just a y squared. 5x cubed y squared needs another y squared to make 5x cubed y to the fourth. Second power needs to be the fourth power. Okay. And similarly over here, if we have a y squared here, then we don't need any y's in this term to get this y squared. We have an x cubed here. We're going to need an x squared in order to get the x to the fifth. And that seems to be pretty clear to people. So let's do it. Let's do one a little more smoothly. Okay. That's 6, a to the 4th, b to the 5th, plus 8, a cubed, b to the 8th. We're just seeing one step maybe what all could be factored out of this expression. Okay, we've seen this pretty quickly. 2 goes into both 6 and 8, so we could put a 2 out here. That would leave us 3 here and 4 here. As far as a is concerned, we have an a to the 4th and an a to the 3rd. The biggest power of a we have is a to the 3rd. And of course, we're going to get an a to the 4th on this term. We're going to need an a. And then of course, the a to the 3rd, when we multiply 2a to the 3rd by 4, we're going to get 4a to the 3rd, 8a to the 3rd. What about b? Well, we have a 5th power of b and an 8th power of b. Okay, so we have a b to the 5th here because b to the 8th contains b to the 5th. I'm going to call that b cubed. I think, I'm not sure everybody got all the exponents copied down correctly, but everything that I saw out there looks good, and we come to a conclusion much like this. Make sense? Okay, well, that's called greatest common factor. That was 2a cubed b to the 5th. And I think everybody sees how to write that. Okay, that's very good. Now I'm going to move on to another kind of factoring. First, expand that. And I'm going to expand it quickly because we see how to expand this. That's x times x plus 4 plus 2 times x plus 4. X times x gives you x squared. 4x times 4 gives you 4x. 2 times x gives you 2x. And 2 times 4 gives you 8. Okay, well, that's then x squared plus 6x plus 8. Then let's notice that the 8 is 2 times 4. And that came from here, well, multiplying the x. Sorry, from multiplying the 2 by the 4. So I'm going to kind of circle the 2 and the 4, because these are kind of the keys to factoring this thing. Okay, and we see that 2 times 4 is 8. And then the 2 plus the 4 comes from these two terms. So I'm going to write another one down. X plus 2 times x plus 3. Oh, heck. For some reason my brain isn't connecting real well this morning. I apologize. Um, gonna write down okay, x squared plus 7x plus 12. Now, notice that what we did here, if we'd have started with this, if we want to factor this thing, we need to find two numbers that multiply out to give us 8. And the same two numbers add up to 6. Okay? Can you find two numbers whose product is 12 and whose sum is 7? What you want to start with is 12 and figure out what pairs of numbers you can multiply to get 12. There aren't that many. Pretty soon you'll come upon a pair that adds up to 7, and then you'll have it. Okay, so everybody quickly found this. Four times 3 is 12. 4 plus 3 is 7. So fill in the blanks. X squared plus 7x plus 12 equals x plus what multiplied by x plus what? Okay, just as we saw up here, when 2 times 4 was equal to 8 and 2 plus 4 was equal to 6, this trinomial, this expression with 3 terms, was equal to x plus 2 times x plus 4. Of course, we started with the x plus 2 times x plus 4 and used the distributive law to get this. We saw this pattern, and then we used the same pattern with different numbers to see what would work here. And we got 4 times 3 is 12, 4 plus 3 is 7. Well, the 2 and the 4 multiplied give us 8. That's where this 8 came from. And there's a 2 and a 4 that you multiply to get 8. And then the 2 plus 4 is 6. When we expand this, we get the 2x plus the 4x, we get the 6x. So when we come down here, we're going to have x plus 3 times x plus 4. Of course, you want to write x plus 4 times x plus 3, that's the same thing. So now I ask everybody to expand this. So everybody go ahead and expand this and see if the result doesn't match the expression you started with. Well, there isn't a lot of room here. I'm going to have to write it kind of small, but everybody got it. X plus 3 times x plus 4 is x times x plus 4 added to 3 times x plus 4. And this equals x squared plus 4x plus 3x plus 12. This is very close to what we got here. We see that our 3 times 4, we have to have two numbers that multiply out to give us 12. 3 times 4 gives 12. Okay. Then, when we do the expansion, we get 4x plus 3x. 4 and 3 make 7, so 4x plus 3x is 7x. Okay. Now I'm going to write down a couple more, let people kind of work through at their own pace, and we'll interject every once in a while. Okay, so let's try x squared plus 8x plus 12. X squared plus 13x plus 12. Then maybe x squared minus 5x plus 6. And x squared plus x plus 6. Let's see how we can do with these. Okay, well, this one factors as x plus 6 times x plus 2. And you can see that you multiply the 6 by the 2 to get 12. It's like here, we ended up multiplying the 2 by the 4 in this step to get the 8. And then 6 plus 2 equals 8. Because, of course, we're going to get a 6x and a 2x, which is going to give us the 8x. And then I'll say check. Everybody appears to be doing fine with the distributive law. Expand these. And there are shortcuts to the distributive law when you expand these. But I like to see the distributive law used because it apparently needs a lot of reinforcement. Okay. Here, well, we'll let people work a little longer to get this one or this one or this one. Okay, accidentally wrote a plus 6 here. This should have been a minus 6. It's not going to work if you got a plus here. Okay, this one. Well, you're going to have x plus 12 times x plus 1, because when you multiply it out as you did here, the same way the 2 and the 4 multiply out to give you 8, the 12 and the 1 will eventually multiply out to give you the 12. And then you have 12 times x, and you'll have x times 1, which gives you 13x. So again, check. You take the time to multiply these out, even if you got them right. You're likely to see the relationships and see the patterns much better. So when we start putting a number in front of x, you're going to have an easier time because that's much harder. That's not going to happen in this assignment, but it's coming up. Okay, so let's see if we get this one. There's a little twist here. Okay, now here we're going to have to get two numbers that multiply out to 6 and add up to -5. How are we going to get a negative out of this? Well, what multiplies out to 6, 1 and 6, 2 and 3. Those are about your only choices. Of course, if they're both positive, you're never going to get a -5. So you're going to have to use either -1 and -6 or -2 and -3. Well, once you see that, it's pretty simple. You've always got to consider possibility. You've got to use a negative. If you do x minus 2 times x minus 3, then the -2 and the -3 give you 6. It's positive. And the -2x and the -3x add up to -5x. And you definitely want to check this. Okay. X squared plus x minus 6. What are we going to do with that? Okay. Well, what numbers can you multiply to get -6? If they're integers, it's going to be 1 and 6, except that doesn't give you -6. You could use -1 and +6, or you could use 1 and -6. Okay, so we just maybe even list these over here. Okay, -1 times 6 equals -6. -6 times 1 gives you -6. Or -2 times 3 gives you -6. Or -3 times 2 gives you -6. There are 4 possibilities for integers. The one that works is the one where the two numbers add up to 1, because you have to have 1x. And that would be this one. So you have then x minus 2 times x plus 3. And now you can look at this and check it out. You know that the -2 and the 3 have to multiply out to give you -6, and they do. And then you have a -2x and a +3x. Well, that's just x, so that works. Okay, and then check by actually using the distributive law and multiplying this out. Get that process down, then you'll be pretty good with trinomials. Okay. Now, if I wanted to be really mean, I give you something like x squared minus 9x minus 36. I'm not going to ask you to do this. I'll just demonstrate what I mean. Okay, what numbers can you multiply to get -36? Well, you could do -1 times 36 equals 36, or -36 times 1 equals -36. Or -2 times 18 equals -36. Or -18 times 2 equals -36. Or -3 times 12 equals -36. Or 12 times -3 equals -36. Or -4 times 9 equals -36. Or -9 times 4 equals -36. Or -6 times 6 equals -36. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 possible pairs of numbers that give you -36. And you can write them out. Or you can kind of think it through. If one of the factors is 36, the other is going to be 1, and there's no way you're getting 9 out of a 36 and a 1, right? So you toss that in the trash heap. If it's 2 and 18, well, 18 minus 2 is 16. Of course, 18 plus 2 is 20. You're not going to get a -9x out of that. Okay. 3 and 12 is what works, because you can put 12 and 3 together and get 9, right? 12 minus 3, or 3 minus 12. Okay. So you then determine you're going to have x squared minus 12 times x plus 3. And I saw the square and wrote one down. Gotta stop following that visual cues here. Okay. Negative 12 times 3 gives you negative 36. Negative 12 times x gives you negative 12x. X times 3 gives you 3x. Negative 12x and 3x gives you negative 9x. Okay. If this had been plus 9x, then I'd put the negative on the 3 and the positive on the 12. Okay. You might want to digest that a little bit. But you see, with an x squared and a 36, I've got all kinds of options for what to write here. Now, I will comment that if this was a 2x instead of an x, you'd be out of luck. Okay. If this was negative 10x, you'd be out of luck. Okay. So not every trinomial is going to be something you can factor over the integers. Okay. There might be fractions that you use or irrational numbers that you'd have to use, but you're not going to find them. Okay. Unless you use the quadratic formula, which I don't think we've talked about yet. We'll talk about that toward the end of the course. Okay. So they kind of hang together. Good. Okay, there are a couple of little twists that can pop up in the homework and in applications. Let's consider x squared y minus 5xy minus 36y. Is there something you could do immediately to simplify the form of this? Is there anything you could factor out before you try to factor the trinomial? Okay, now this one factors, but first, it doesn't look quite like the others because you've got both x's and y's, and that can cause a fellow to go blind. Okay, it didn't, but it could. In other words, you're looking at it and you just don't see the pattern. Well, that's what I'm going to show you. There's a y common to all these terms. So the first thing you do whenever you try to factor an expression is you factor out the single terms, the monomials. Okay, so we can factor out y here. We have y times x squared minus 5x minus 36. And then, well, I've already factored one with a minus 30, with an x squared and a minus 36. And when we had a negative 6x, as we saw here, from it, sorry, negative 9x, we had to use negative 12 and 3. Okay, well, you can think through all the pairs of numbers that add up or that multiply out to 36. Pretty soon you're going to hit on the idea that, well, 4 times 9, because the difference between 4 and 9 is 5. Okay, so you've hit it, you just got to get the right signs on things. So that's going to be y times x minus 9 times x plus 4. And you think it through. The 9 times 4 is going to give you 36. It's going to be negative because the 9 is negative. And then negative 9x plus 4x is negative 5x. And it works. Okay. So the lesson Factor out the greatest common factor first, okay? Okay, let's try another one. Let's try this. Let you think about it for just a minute or two and see if you come up with an idea. And then I'm going to show you what the trick is here. Okay, so we got this expression. Now, this is another one of those that until you see what's going on, it's kind of difficult to do. Okay, so I'm going to just say, okay, well, let A equal x squared. Then x to the fourth plus 2x squared plus 1 would be equal to a squared, because of course a is x squared, and you square it, you're going to get x to the fourth, and x squared is just a, so 2x squared becomes 2a plus 1. Okay, and now we can factor this. And I think we're okay with factoring this. You get a plus 1 multiplied by a plus 1. You don't have a lot of choice. You got 1 here, your factors are 1 and 1. And they better add up to 2. Okay? Or they could be -1 and -1 and add up to negative. In this case, it's got to be 2. Well, okay, that's a plus 1 times a plus 1. And that's just x squared plus 1 multiplied by x squared plus 1. Okay, and then you can check that and multiply it out. The idea is, if this power is the square of this power, then you can always do this. Okay, this power is the square of this power. In other words, if this power is twice this power, then you let a equal this power and you can simplify it. You'll see examples of that kind in the homework. And, you know, in the videos and so forth. Okay. Okay, well, we're 3 minutes short today, but often run over a minute or two. So that's all we're going to do today. Okay, so it's basically just a bunch of factoring. I don't think you're going to have any serious trouble with it from what I've seen.